Hi to everyone, I'm Federico Ortenzi and I'm here to present our research that is entitled Multifunctional Biocidal Mortars based on nanoparticles and organic waste material for the cultural heritage conservation. This research was carried out by Yokoku in collaboration with the Ecological Park of Ostia Antica, with Brinova Biochemistry, with the University of Calabria and with ISAC CNR Institute. So our research arrived from an issue, the issue of biocolonization. That is a very well-known issue for the cultural heritage sector. In fact, this is a well-studied phenomenon that is very complex and dynamic. The biocolonization process is a multiphasic process in which such defined colonizer organisms that are both micro and macro grow onto the surface or pores or crack of the target site, and during the process the site is altered by physical, chemical and biological processes, so that at the end and during this growth the site requires an intervention. So in the cultural heritage preservation, there are many approaches under the focus in order to prevent this phenomenon, and the focus is under the finding of novel approach in order not only to fix and restore the site, but also to prevent biocolonization by using a material that retains biocidal activity, and this material has also to retain a low environmental impact. In this scenario, many novel and promising solutions came from the discovery of nanotechnology. In fact, from nanotechnology, one of the most known nanoparticle used in the sector is titanium dioxide. That is very well known and it's already employed in paints. But the usage of this nanoparticle raised many questions for the safety and for the environmental safety. And thus, nanotechnology is under the focus and under the assessment of long-term study. Our research has thus the aim to formulate and test the effectiveness over time of novel and multifunctional mortars that retain biocidal activity, and to test the efficacy of those mortars in preventing in situ biocontamination. To do so, we decided to employ two approaches, one based on the manufacturing of nanoparticle-based mortars and the other that instead is based on organic-based mortars. The choice of these two approaches comes from a bibliographic study. In fact, for what concerns nanoparticles, we carried out a bibliographic research in order to find nanoparticles that had three main characteristics. They had to be biocide, so to retain a biocidal activity towards biocolonizer. They had to be easy to synthesize, and they had to be biocompatible with the operator. So in this research, the enlisted nanoparticles emerged that satisfied all the requirements. In specific, zinc magnesium oxide nanoparticles, it's a very promising nanoparticle that was shown to inhibit the epilytic and endolytic colonization and to retain a great antifungal effectiveness. Another interesting nanoparticle is silver oxide nanoparticle that showed not only antioxidant and antimicrobial effect but also antifungal, and is very promising, being non-toxic and biocompatible for the operator. Thus, we decided these nanoparticles and we carried out their synthesis by sol-gel method. Hence, we dispersed this nanoparticle in water and we mixed them by sonication, and we made up mortars in order to make up samples and to deposit them into the target site. For what concerns organic material, instead we had to satisfy three characteristics, and our bibliographic research followed these parameters. They had to retain a biocidal activity, but they have even to be and to retain and to keep the flexular properties of the mortar. In addition, we were looking for compounds that entered into the circularity model, thus that were resources that were considered waste but that could be reused and reallocated for another function. Thus, our bibliographic research led to the finding of pine needles and caffeine powder for their reported efficacy as mortar consolidant and as biocidal compounds. What we did with organic matter was a pre-treatment that was, in the case of pine needles, their cutting; in case of coffee, its heating, and then we dispersed this organic matter in water to make up cementitious composites, thus mortars, and to deposit them into the target site.
So this research was divided in 3 steps. The first one was the manufacturing of the mortars that was done in July 2021, and it consists on manufacture nanoparticles based mortars and organic based mortars that were produced with waste materials. And then the second step consisted in placing those samples, those mortars, in a real case study in situ, and it was chosen the archaeological park of Ostiantica, and they were placed in October 2021. The third step, that is still ongoing, is the monitoring of those samples to check if in time there is a regrowth of bioterogens. So as you can see in this slide, here there are the samples of those mortars, part of which were studied in laboratory and were inoculated with common outdoor fungi, that is Cladosporium, and they were incubated to study the in vitro biocidal efficacy. The other part were placed in situ in the archaeological park of Ostiantica, actually in different spots to see the different reaction. The first part was exposed in the outdoor, exposed to the atmospheric agents. The second part were instead still in the outdoors, but not exposed to the sunlight and to the atmospheric agents. It was still not possible to see a visible regrowth on both the mortars placed in the laboratory and in situ. The experiment consists in testing both the laboratory and in situ samples with inorganic and organic formulation to analyze their biocidal efficacy. The laboratory testing and monitoring will be done by agar diffusion assay, by analyzing the difference in ATP of the metabolic activity of microorganisms using a bioluminometers, by analyzing the difference in the red re-emitted light of chlorophyll with UV fluorescence imaging, and then by analyzing the difference in colors of the surface of those mortars using a spectrocalorimeter and analyzing then the chromatic parameters L, A, and B. For the in situ monitoring, the testing will be done by analyzing the ATP of the microorganism, then the red re-emitted light by chlorophyll, and finally to analyze the different colors of the surface. To monitor during time the biocidal efficacy of those mortars, the analysis will be done in different periods. After the carbonation of the mortars, after 6 months from the carbonation, and finally after 1 year, to see if there will be a regrowth or not on those samples. After all this time, we will collect the data and analyze it to see which sample between the inorganic nanoparticles based mortars and the organic based on wasted materials mortars had the best action. And here we conclude our presentation. We hope you enjoy it. And don't hesitate to contact us in case you want more information or you want to give us some advice. We thank you all for your kind attention. Have a nice day.